So, who am I? I'm Paul Fremantle, and I'm a CTO and co-founder of a company called WSO2. We make middleware, both cloud and on-premise. And I've been working in Apache for nearly 10 years. I did my first contribution to Apache in about 2002. And I started some projects and been involved in quite a lot of incubator projects. And kicked off Apache Synapse, which is an ESB, and I'm the VP of that project. And before I set up WSO2, I was at IBM, where I was a senior technical staff member, and I worked on WebSphere development for my sins. And I had a great time at IBM, but probably that was what pushed me out. To deal with too much WebSphere, but never mind. And if the internet fails and the demos go wrong, you'd probably get some of my tin whistle, because that's what I do when everything else fails. So what am I hoping that you're going to take away from this presentation? I was trying to think, well, what would it be useful for people to walk away having found out? I think one of the biggest problems with platform as a service is there's no clear definition, and everyone has a slightly different view. So I'd like to kind of talk about some different angles of that and think about what a platform as a service means. I'm a big believer that a platform as a service should be open. So I'm a big believer in open PaaS, and so I'm going to try and persuade you that that's a good thing. I'm going to talk about the PaaS that I've been involved in, which is called Stratos and Stratos Live, and I'll explain that. And hopefully you might even try it out. Some of you have got your laptops open, you can have a go if you get bored with this to me, you can try it out. And obviously where you can get more information. So if that's not what you want to learn, I won't mind. Use your feet, walk out, leave now, or leave halfway through it if you want to really depress me. But and my Twitter tags down there, I'm quite easy to find. So let me just give you a little bit of motivation first, which is that data seems to be doubling every 15 months. So if you look at, I did just a bit of research on how many exabytes there were on the web, and from 2002 to 2009 it went from 5 to 281, which if you do a little bit of maths comes out to be doubling every 15 months. And of course that data is not just more rows in the same tables. It's new tables, new databases, new shapes. So it's not, you can't just say, okay, I'm going to pay Oracle twice as much every 15 months, because that's not going to work, because the data is scaling it. You can't just scale up to existing data servers. And of course, it also means that those applications that are written to deal with those tables that you have today aren't going to provide insight into that new data. So you need to write apps faster. I've just been in a keynote that says you can't write apps faster. I thought it was a really good keynote, but I think he got the title completely wrong though, because I came away with the message that it's about quick and clean, not slow and dirty. You seem to be saying, you write it clean and you can be quick. So, but and I think that's actually one of the aims of a platform as a service, in my view, is to have the right infrastructure so that people write apps in a good way, even when they need to write apps quickly. So that's actually, I think, fits in very well with the keynote. So you need to write more apps, and we all know that what happens is people write applications, and some applications end up dying and never seen it again, just like some startups die and they're never seen again. And some applications, and not always the ones we expect, are the ones that take off and succeed and grow. I remember one summer I wrote a small database for a charity to keep details of their contacts. And about 4 years later, I got a phone call from them saying, it's not working. And I'm like, oh yeah. I didn't expect them still to be running it, let alone phoning me up in the middle of the night it was, saying it's not working. So, you know, you don't know which apps are going to succeed. And so it's important that when you do write apps, that you have the right foundation and that you write them in a good way. So let's just step back and think about what you think cloud is. And we're all sort of techies, so we probably think of cloud in terms of people like Amazon and Rackspace and stuff like that. Yeah, if you're my daughter, you probably think cloud is iCloud, because that's her only experience is through Apple. If you're my mother, you think cloud is Gmail, because I set her up with Gmail. If you're my sales director, then you probably think cloud is just your prospects in the cloud. There's a gap here, which is the sort of people in the middle, which is us, which is the developers. Right, we're not sysadmins, and we're not particularly, I mean, we are probably users of software as a service, but that's not our focus. And this is really where platform as a service, I think, is aimed, is to provide something for developers. There's something between just the machine and the software itself. And of course, having worked in middleware for 10 years, this is the space I work in, which is somewhere between the machine and the applications. So naturally, I'm interested in platform as a service, both as a developer and as a creator of stuff. And I think we've seen people coming at it for both ways. So Force.com really got created out of trying to allow Salesforce users to customize their domains and their tenants within Salesforce. So that's really where that platform as a service came out of. It's trying to say, well, we can go down from software as a service and create and fill the gap in that way. If you've used OpenShift, or if you're involved in OpenShift, that's much more this way. It's really a DevOps operation where they're saying, well, we know how to manage and configure machines, and we're going to help you do that in this sort of way. And that's pretty much where Elastic Beanstalk is. Has anyone used Elastic Beanstalk? Elastic Beanstalk is basically a way of sort of quickly bootstrapping Tomcat type web apps. So, I actually feel I sort of have come into this more this way, which is that I've been building middleware for 10 years, and now trying to say, well, how does middleware fit in the cloud? And so about 3 years ago, we sat down and we looked at our middleware and we said, well, you know, what do we want to do in the cloud? And to start with, we had no clue at all, because has anyone heard this phrase, cloud washing? Cloud washing is when you take your app and you put it on a VM and you stick it up on the web and say, hey, we've got a cloud offering. It's a AMI for Amazon. And it's kind of like taking exactly what you have and saying, hey, it runs in the cloud. And that's not really very exciting. And I thought, well, that's not very interesting. Why would our customers care about that? So what we came up with was we tried to think, well, what does it mean to be interesting in the cloud? And we came up with this set of categories. And I'm not sure they're quite right, but I think they're an interesting starting point. And I actually think these apply at all those levels. I think they apply at the infrastructure level, I think they apply at the software level, I think they apply anywhere. Which are, you know, you need things to work properly in the cloud. So you need stuff to be distributed and sort of dynamically wired. So you don't want to take your SAP system that isn't very scalable and flexible and create a cloud image of it, because you can't bring it up and down, you can't move it around, it doesn't necessarily give you any benefit to put it on VM. I think elasticity is the one thing we've all seen a lot of focus on in the cloud. I've not seen a huge push for this from my customers so far, from people I talk to. I mean, there are people with elastic workloads, and there are a few cases. And I see really two problems with this. One is a lot of people's business isn't that elastic. And so that's not really that exciting to them. And secondly, there's a lot of people who have data inside private networks that cannot be moved into a public cloud. They have regulatory issues, they have security issues, they have all sorts of reasons they can't put the data out there. And they look at their internal workload and they say, well, everything bad in my company happens on Thursday afternoons. That's when all the systems are loaded. If you're in the video industry, you do a lot of transcoding to get your video to the advertisers on Friday. Or everything, eBay is one of our customers, and everything that happens to eBay happens, very shortly on Cyber Monday, when they get their heaviest day of the year. So having a private elastic cloud isn't much good to them either. So this has not so much been the focus. I think what people have said to me, why they're interested in cloud, is about self-service. It's about being much quicker at getting stuff up and running and managing it, and being able to put the control into the hands of the users, whoever those users are, whether it's the sysadmins or the email users or whoever it is. An aspect that I think we're going to see a lot more interest in is multi-tenancy. There are not many PaaSes today that really care about multi-tenancy that much. They do, but it's done in quite a basic sort of way. I think multi-tenancy is very, very interesting, and we've seen, there are companies out there who've built multi-tenant systems 10, 15, 20 years ago, and they're sort of thinking, why isn't anyone doing this? I think there's some two reasons why multi-tenancy is interesting in a platform as a service. One is about a cost issue, which is that you can share a lot more stuff if you have a truly multi-tenant architecture. So, for example, lots of companies I talk to have 200 Tomcat servers. And out of those 200 Tomcat servers, 5 of them are doing something hard and high volume. 95 of them are low volume, sort of odd little apps that get used once a day or once an hour or maybe twice a minute or something. And then 100 of them are test servers that get also used infrequently. Now, if you could put all those 100 test servers into a set of shared instances, and you could put all those 95 low volume instances into, say, 2 servers, and then leave those 5 servers that are really doing what they're doing alone, you've got much more utilization than even if you put them on VMs. If you put those 95 servers on VMs on a shared infrastructure, you're still sucking a lot of memory and a lot of CPU time with the virtualization that isn't necessary. So I think multi-tenancy is very interesting from a resource point of view. But it's also really interesting because a lot of people want to build software as a service, and I think having a multi-tenant platform as a service helps do that, and I'll talk through that later. Of course, once you've done all of these things, then you better start metering and billing properly, can't you? You don't want a situation where people can create their own infrastructure. I don't know what that is. People can create their own infrastructure and elastically scale it up and all sorts of things, and then you don't know who's using it because they're going to cost you a lot of money. And then there's one aspect that I think is really important that we're going to see a lot more of, which is how do you deal with incremental deployment and testing in the cloud as well? So how do I install version 2 at the same time as version 1? And when do I switch them over from live? Can I, for instance, have version 2 and version 1 both in production and start sending 5% of my live traffic to version 2 to see not just how it has it passed its unit test and everything else, but what's the impact on the CPU time, for example, when I do that. So we sort of looked at all those things, and then we said, right, we need to apply those to an enterprise architecture. And without being too rude about all the competitors, I think most of them are focused on this one thing, which is web apps. So, hey, I'm going to let you manage a web app as one of those cloud native things. And I've spent a lot of time at IBM and all sorts of places saying, well, web apps are not the only part of my enterprise infrastructure. I think it's kind of like a bit of a back to the 1990s kind of thing. But a lot of people have moved to cloud and they've sort of said, well, okay, I'm going to build a monolithic application, and it's going to just going to sit as a web app and be written in the cloud. And that hasn't worked. And that's exactly what happened with Twitter, was that they built a very basic app and then they realized they needed all kinds of messaging to make it really scale out. And so I think there's a whole bunch of other things, and this is not a conclusive list, that people need in their enterprise architecture. They need queues and topics. So who uses asynchronous messaging in their apps? Quite a lot of people. So, we've seen that, for instance, Amazon have their simple queue service, which sort of provides that. Probably a much better solution is something called StormMQ that offers a proper messaging service as a cloud offering. Obviously, I would guess everyone uses databases as part of their rollout, so you need some kind of provisioning and management of databases. Does anyone use a role server or a CP engine? So again, if you're going to have a cloud offering, don't you want to have that somehow as a cloud native offering? Lots of people use ESBs. Some of you may use business processes. Some of you may have portals. So I'm a believer that everything you have in your enterprise architecture, you need in your platform as a service. And what we've seen at the moment is we've seen some very fragmented stuff. So we see some people like, so I probably shouldn't name this, but say Cloud Foundry, right? It's a very web app-based PaaS. So it's what people might call an application PaaS. And it's growing very well because it's got a very nice plugin architecture. So we're seeing other services being plugged in by third parties. But the kind of droplet mechanism is fundamentally HTTP based. Right? So, and then we see like Mule Ion, which is an integration PaaS, and there's database.com, which is a data PaaS. So we're seeing a lot of these. My prediction for the next few years is they're going to merge, and we're going to see and consolidate, and we're going to see sort of complete PaaS. There's also a lot of boring things that you also might be interesting that I haven't even put in here, like log as a service. There's a great company called Logly that offers that. So, and the billing and metering, I think people want to see not just happen within the PaaS, but also as a offering. So, okay, so I think I'm trying to explain what a PaaS is. I said, there's not much agreement. There's this various categories. I think those categories are going to vanish. I think people are going to add more and more services into their platforms until you see pretty much all of that. So for instance, Google App Engine, seeing them adding in more and more services into the mix. Cloud Foundry, you're seeing that. Some of them are ahead of others, but definitely you'll see lots of services into those platforms. And I think that's one aspect and one dimension, is which services it offers. But there's also which languages and APIs. So, for instance, some PaaSes are very, very good at handling multiple languages and multiple runtimes. Some are not so good. This is a dimension. We're very Java-based, so we basically run Java and JavaScript, and that's about it. I guess BPEL counts as a language, but some are let you run Ruby and so forth. I think a really important category is it available to run on a private cloud? Can you take this platform and say, can I run it somewhere else, or can someone else run it? And to me, that's really important. So Google, for instance, put up their pricing for Google App Engine about a month ago, 6 weeks ago, and a whole bunch of people found their apps were now costing twice as much as they had before, in some cases 4 times as much. And they're all scratching their heads going, what can I do? Where can I take this? And it suddenly occurred to them that this app was not able to run anywhere else except on Google App Engine, and they had to rewrite it. Now that might not have been very apparent, because Google App Engine uses lots of open source. It uses lots of nice things like Django and Spring and all sorts of cool stuff, and they're like, this looks like an open source stack to me. But it's using a lot of very Google-specific services under the covers. So it's not very portable. Even though the code is portable, you end up writing code that uses Google's identity, Google's big table, Google's this, Google's that, and a lot of models that Google provided, and so you end up locked in. And being an Apache guy, I think open source is also very important. Because even if you can run it on a private cloud, and it has a lot of open APIs and languages, if it's a closed source offering, I think you're in the sort of typical Oracle domain, and I have a lot of customers who say they're very badly locked into stuff. And I think platform as a service is particularly at kind of a new locking point, which is why I'm kind of stressing this. I really think that it's an opportunity to lock people in, and people are saying, hey, this is, vendors are saying this is a fantastic opportunity to get people stuck on my platform. I used to, I shouldn't say this, is probably breaking in terms of my confidentiality. I used to have a manager, not a manager, a sales guy. He ran sales for WebSphere for Europe. And he said, we are heroin dealers. That was his message to the sales team. That once you got people hooked on WebSphere, they would be hooked for life. And that was his actual metaphor. And I found it a bit shocking, really, because it's not a pleasant thing. And I think there are plenty of people who are thinking, oh, we can get people hooked on our platform, and it's even better than software because we're running it for them as well, and they've got their data locked into our platform, and they've got their code locked into our platform, so it's complete locking. So who's out there? Well, we have a bunch of people who don't have a private platform as a service, and I may be wrong about some of this. I did my own research, so Force.com, Heroku, Google App Engine, Amazon Elastic Beanstalk. There are some where they private and public PaaS, so Tibco, Microsoft. CloudBees has sort of just launched their sort of on-premise PaaS. I haven't had a look at it. You have to sort of just fill in the form and prove to them you're a worthy beta customer, so it's not the sort of thing you can just download and have a go with. Spring Source has sort of got some of both. It's not quite in full support production. I think we've got a very good story on this. Red Hat OpenShift, I haven't seen the download, but it's a big premise of theirs, and they're very good at open source, so I believe them. Maybe it is available somewhere, or in a code repository, but I haven't actually been able to find it to download. So, and have I missed anyone of interest? Okay. So there's a bunch of these people, and of these, who's doing well? Well, obviously, Cloud Foundry is doing very well. They've got a lot of momentum. They've got a great organisation behind them. Microsoft's interestingly doing very, very well with Azure. And the reason is they've really focused on taking existing apps and runtimes and putting them in the cloud. And then they've put a lot of focus on what's different about the cloud. So they've got a really nice cloud service bus as part of Azure, and some pretty good data stuff too. They've done pretty well on the queuing and data aspects. So let me now tell you a bit about Stratos and Stratos Live. So this is an open source product and project, which is also running as a service. And this is a really key, we think really key, which is that our platform as a service is a product that's running. It's not a sort of an interesting glued together collection of stuff that we've somehow magicked up to run as a service. It's really the product. You can download it and install it yourself. I'm not saying it's that easy. It's quite a complex setup to do that, but it's possible. It's based on OSGI, so we have an OSGI runtime. And we don't do all of those native features I said, so we don't yet have full support for incremental deployment. We have got billing and metering, we have got multi-tenancy and elasticity, and self-service obviously, but we don't yet have the full ability to deploy apps side by side and say, what's happening. And Stratus Live is the same thing running in the cloud. I suggest that you sign up. So let's just have a look. The demo. It does seem to be working. So if I go to stratuslive.osfg.com, what you can do is just click on Get Started Now for free. And you have to choose a domain. So you're not registering a user here, you're registering an organization. Of course, that could be you. But it's, once you've registered the administrator, you're then able to go and add as many users as you like. Well, I say that, there's different levels of pay, and there's some limits on the users based on how much you pay. But in theory, if you're willing to pay, you can register more users. If you just want a free demo, then you're pretty limited. So the way this is actually running is that there are multiple servers here. And basically, as I said, there's a bunch of services. What we had was we had a set of middleware products. And they're all based on this same core OSGI runtime. So what we did was we actually basically went multi-tenant, elastic, metered the core. And the result was that now we have all these things available in Stratus. So it's kind of it wasn't on purpose. We used OSGI and componentization just to save us development time. Because if everyone uses the same core, people can be much more productive in building stuff on top of it. So, each of these products has probably, some of them have more, but for instance, our message broker product has got a development team of 3 on it, because it basically, they're just focusing on the broker part of it, and someone else is focusing on the admin console and the clustering and all the other pieces. So that's our kind of model. So now I have a sort of virtual middleware environment with all these servers. And there's a slight lag in starting some of these up, so I'm going to kind of be cheeky and start up a couple. And why you see Stratus identity here is that basically all of these servers are running on different machines in our cluster. And we use single sign-on across them, using SAML2 single sign-on to basically give you a consistent identity across it. So there's some kind of single sign-on hops going on back and forth, which is a bit slow. So the kind of obvious thing you would want to do in a PaaS is to go and deploy an app. And so you can go to our app server, it's basically a Tomcat 7 runtime. So you can go and deploy a WAR file, you can also go deploy JAX RS services. But there's also a set of other things, like for instance the data services server lets you go and provision a database, either a Cassandra database or a MySQL database. Go and say, I want this database, create your own little space, provision it, and deploy it, and you can also expose those data sources as RESTful services or SOAP services out to the web. The mashup server is basically a sort of server-side JavaScript runtime. The identity server is doing that SAML2 single sign-on. It also does stuff like XAML. The governance registry is, these two are actually kind of core parts. You can turn all the rest of this off, you can't turn these off. The governance registry is not just a governance registry, it's also a configuration registry repository. So we use that to store all of your own code and configuration for that tenant. If that makes sense. The gadget server is basically a portal based on Google Gadgets and a project called Apache-based. Business Activity Monitor is a portal built that shows you stats about the system. The Business Process Server is a project is based on Apache OD, it's a VPOL runtime. The Rules Server is based on rules. The ESB is based on signups, and the message broker is based on a project called Qubit. So you've got a set of these. Now, this is what I mean about this being quite a different PaaS that came from the top or the side than the one that came from the bottom. Because if you look at, say, OpenShift, or Elastic Beanstalk, they're very focused on provisioning a server and sort of running it automatically. And it's much more about provisioning and monitoring. This, you don't really have much clue how we're actually provisioning and managing these servers. I mean, what's actually going on is that we have an Elastic cluster and we have an Elastic load balancer in front of the cluster that siphons work off to a particular app server that's running your logic on it. But that's one particular deployment model. Now, my personal view, and this is maybe where I come from, and you might completely disagree. My personal view is that as a PaaS, I don't really want to care about what this is running on or how it's running. What I want to care about is, are my response times being met? Is my availability being met? And show me my app. Can I deploy my web app? Can I deploy a new version of it? Can I see how many hits it's getting? Can I monitor it? So from my point of view as a developer, my personal point of view, I think the sort of Gmail equivalent, the software as a service equivalent for developers is to say, you know, I don't care where my email is stored by Google and how many servers it's running. I don't care about that infrastructure. I just care about my inbox. Well, I just care about my app, or my queue, or my data store. So that's my personal view, and you may disagree. So how's this being used? Well, to be honest, not many people are using what I just showed you, Stratos Live. We ran it in beta for a year. We got about 1,500 people signed up, of which about 10 were actually doing something serious with it. Right? Which is fine by me, because we have a lot of interesting projects around Stratos, which is really where which is where our customer base is. Our customer base are customers like eBay, Deutsche Bank, Federal Home Loan Bank of San Francisco. You know, they're people who do not run their stuff on a public cloud. They run it inside their data center. So most of our customers are taking the code behind this, the product behind this, and deploying it in their data center and doing some interesting things. So we have a system integrator that basically is running this. They're using it for internal as a place to host internal apps and for developers to host and test apps, with the idea of basically using it to host their customers' apps. So for them to go and become a service provider rather than just a system integrator. We have a bank in the US which runs their middleware infrastructure is Carbon, which is our on-premise non-cloud version. And they run this as a cloud thing for dev and test. So basically developers can create an infrastructure to deploy their apps and then test them, but then actually take those apps and deploy them into their static infrastructure for runtime. This is the one that I think I'm most excited about, though, which is that we have a bunch of customers doing what I'm calling an ecosystem PaaS. The ecosystem PaaS is the idea that you might be providing a service or you have some kind of business. You provide a set of services and APIs in that business, but then you let other people come and customize those and create something for their customers. So has anyone heard of the Connected Car Initiative? This is something that's happening in various countries, but in Germany there's an initiative to put a device in every car that can do fleet management, traffic management, but also things like you push a button and it makes an emergency call and it sends your GPS location to emergency services. And one of the organizations that's trying to build this out wants to not just have their apps in the car, they want to allow other people to put their apps in the car. So they basically have a set of their APIs, traffic management, fleet management, and so forth. But they also want to let third parties run on their server infrastructure close to the car in network terms, apps that are available to the car, and at the same time put the mobile app into the car, into the device in the car. There's one kind of ecosystem PaaS where you basically take your services and there's a combination. These tenant apps use these services plus their own thing to expose something to the users. So why is that interesting? Well, imagine you're a mobile phone or a mobile telco. 10 years ago, you were making huge profits because you owned the infrastructure, you owned the content, you owned the users, and then along comes Android and iPhone and tablets and stuff, and now you're just being piped for IP packets. Okay? And you're making some tiny, tiny margin on that. So they don't want to do that. They want to say, well, okay, we're going to provide infrastructure for cars to have this infrastructure, but we're going to just be the IP packet switching network. That's really boring. We want to say, well, we want to provide an environment where we can help other companies build out interesting apps and share the profits of them. So similarly, we're involved in a gaming situation where there's a gaming betting company that wants to allow third parties to build their own gaming apps that share the same odds services, share the same back end, runs in the infrastructure of the gaming company because they're the ones who are regulated to run this kind of thing, which is an interesting twist on this. So I think this is really interesting, the sort of combination of saying, well, you can actually extend your platform to your partners and let them run code in your platform that shares your services and build out something of different value. So I think that's quite exciting.
That would be kind of Salesforce.com model then.
That's basically what Salesforce.com is doing with Force.com, is saying you can go and customize your app around Salesforce to do something else. Yeah, absolutely. So I had to jump ahead, so let me do that. So, okay, so I want to tell you about Stratos. It's an open source project. You can download the code, you can join the mailing list, you can read how to build and install it, or you can just try the service. So those are your options there. If you want to install it, there's basically two different installs. There's a full installation, which requires multiple machines and an infrastructure as a service underneath it, and so forth. So you need to install it on Amazon or Eucalyptus, or we're adding support for OpenStack, and we've got some partial support for VMware. It's not complete yet. Or there's also like a simple install, we call it the local installation, which basically just runs it on a machine. And I say lots of memory, but in fact it's not that memory, it's about 4 gig machines, okay. And basically you just need a JVM, MySQL, and Perl to run some script. And that runs it. So basically, instead of running it in an elastic fashion with a VM manager, you're running it in a static fashion. You're running it not elastically, but you're still multi-tenant. You still get all the self-service and the full stack, but it's not auto-scaling up. Because obviously, there's no point auto-scaling up on a laptop because you're starting more VMs on the same machine. It's not going to be much use. So it's really for developers for us. And it's pretty damn easy to install, actually. You have to configure MySQL, you have to set the root password for MySQL, and then enlarge some network setting. We recommend you up the number of file handles, because this is running a lot of JVMs. You unzip it and run a setup script, and then you say start all, and about 10 minutes later you've got about 10 JVMs running, and it's there. So, of course, there's no point writing a web app, especially in a public cloud like this, unless you can do something with it. And because we're running your web app in the public cloud, we put a bunch of security controls on there. So we don't allow you to open a file. We don't allow you to run system exit, things like that. So there's a bunch of stuff that we've put on the security controls. But what we do allow you to do is provision a database and connect to that database and access the database. And in the previous version, you had to basically go and pay Amazon for your own RDS instance, your own database instance. And of course, you're paying that by the hour, not by the usage. So what we've done in this version is basically actually multi-tenant database. So you can set up a database within our RDS instance and pay by usage rather than pay by time, which is how I think all cloud stuff should be. And that's one of the big problems with Google App Engine's price changes, was that they changed it from a usage-based model to a time-based model. You don't want to be having to pay for time when you're not using it. Similarly, you can also create a key space in Cassandra. Does anyone use Cassandra? So we have a Cassandra cluster running, and we've put in a little bit of multi-tenant code into that, so you can basically bootstrap your key space. It's isolated from other people's key spaces. We take care of that. The user identities are plugged into the identities for Stratos, and you can basically go and create your own key spaces and column numbers and stuff.
And so from your web app, are they just data sources, or are they?
They are just data sources, yes. So in fact, there's basically a way you go and provision that. Well, the Cassandra ones are not yet. I mean, there is this JDBC driver for Cassandra that we're going to be using as well. So they can be a data source. In Cassandra, so for MySQL, they're data sources. For Cassandra, you basically just you just use a Hector API and we give you a URL to connect to.
Has a resource adapter? Has a resource adapter, or is it just a straight?
Just as a straight piece of code, no.
Okay. So obviously just Tomcat, not.
Yeah.
That's why you have a resource.
Yes. And there's a bunch of other services, and this is kind of trying to put it in a slightly open source aspect. So there's this Shindig-based portal, there's Cassandra, there's the JAWS runtime engine, there's MySQL is not part of the product, it's a separate install, but it is part of the service. Kubernetes access too, there's an OAuth. And there's also like a logging infrastructure, so all of your tenants' logs get siphoned off and separated and presented to you. So you can see just the logs for your tenant as well. So it's kind of important. The billing and metering is pretty much at our level at this point in time, in the sense that we meter various things that you're using. So we meter your sort of disk space usage, your CPU usage, things like bandwidth and number of users. And so they have to fit in within a plan. But one of our aims for the next version is to allow you to basically start metering stuff that you want to bill on or you want to meter on. So in other words, making up another service within this set of infrastructure. You can say, I want to meter this stuff, I want to bill it. Because we see a lot of people putting it in private clouds who want to do that. And another thing we're very keen on is that everything has its own network API. So all these services are network accessible, usually as SOAP and REST, sometimes just SOAP, sometimes just REST. And there's two reasons. One is to do automated provisioning. So for example, there's a lot of APIs for deploying code into here, and there's some command line tools that basically can deploy code. You can connect your Eclipse environment into this and just say, right, I will use this as a remote server, give my tenant and deploy code into it. But you can also provision users and do all sorts of stuff using well-defined network APIs. We've had some interest from people. One of the other use cases is saying, suppose I've got some software that's not multi-tenant, but I want to make it multi-tenant. So I'm basically still going to run a VM or a process per tenant, but it's going to share a multi-tenant identity store, share a multi-tenant configuration repo, share a multi-tenant log target. So there's going to be a lot of multi-tenant infrastructure for those people. So that VM is going to be very simple and lightweight and not have to have a lot rewritten. if that makes sense. So the multi-tenancy is an interesting aspect. The way we do it is that all of those services you've seen can be all shared at the VM level. So we're basically doing isolation within the JVM between tenants. Now, of course, that may not be perfect in all cases. This comes back to my thing about the 200 web apps, that I wanted the ability to put some of them together. I don't necessarily always want to put some of them together. So our model is to say, well, we can put them all together, but we can also split them out. And how do we split them out? With something we call the tenant-aware load balancer. So basically, as traffic comes into Stratos, we can basically siphon it off to a particular VM or server based on its tenant. So you can then repartition it how you want to. But there is, of course, a lot of isolation in there. There's, and there's things like stuck thread detectors so that we kill slow running services and so forth. But of course, this isn't perfect. The JVM wasn't designed for this, and so there are reasons why you might need to say, actually, I need to run this app or this ESB flow or this for on its own VM. The other interesting thing that you can do is you can actually deploy a web app that's available to all tenants. So we have what we call a super tenant model. Basically allows you to say, I want to mark this web app as being available across tenants. And that's something we're doing more work on, which basically allows you to write software as a service and deploy it and get a lot of the kind of infrastructure ready for you. So there's a set of services, and I would suggest you have a play with it rather than talked about that. And then where are we going? We've just done the 1.5.2 release that happened yesterday, and the platform is being bootstrapped. And then we're also doing some other stuff. We're doing a project which involves a lot of workflow involvement. So instead of it just being a place to run your stuff, we're also helping manage the project and the product as well. This is basically a customer who wants to say, well, my partners are going to deploy code on here, but it's got to go through a workflow process before I make it available. So effectively, when you register as a tenant in that model, you get an SVN tree, you get a build process, and so forth. So as you put code in there, you can then sort of use specialized VM checking tags to say, push this into the next step. That kicks off the VPOL process that runs a workflow that also talks to their project management and so forth. And we're going to be also productizing some of that back into Stratos and Stratos Live. So I think that's really important, which is that it's not just about the infrastructure being right to run it, but you also want the right model to build it as well. I mean, I really like that, when I create a tenant inside Stratos, I get a continuous integration build system, I get a test environment, and actually we've done that for test harnesses as well, and that should be there in sort of first half next year, the ability to basically upload your test harness into Stratos and schedule it to run against the system. We're doing quite a lot of work with mobile and API management, so we're doing a couple of projects with mobile service providers, and some vertical stuff. We want to kind of step on the toes of the IaaS a little bit by saying, well, okay, I've got all this stuff, and it's all very nice saying yes, I want to just see the web apps and the queues and the databases floating in the cloud and managed by you. But actually, you may just have a bit of C code that you want to run, and so being able to deploy a VM and manage that's kind of important. And we're also adding HDFS support for file system and then Hadoop support to do data analysis in this as well. And then the final thing we're working on is kind of interesting, which is that we get a lot of feedback from our enterprise customers saying our stuff's easier to use than Oracle's or IBM's or whatever. So we get feedback from people saying your middleware is easier to use than the average middleware. But that doesn't necessarily mean it's easy to use, it's just a scale. We're just in this blinkered scale of writing middleware code. And of course, as soon as you pop up this screen here, which is not working unfortunately, but as soon as you pop up this screen, you say, I'm looking at this and I'm thinking, I don't want all this crud. I just want to say, look, I want a really simple model to build an app and define my data model and, you know, define the queues or whatever it is and deploy it. And so we're trying to say, well, okay, this made it really simple to provision middleware, but is there a sort of simpler view of this that we can give people? So we're basically building kind of a JavaScript DSL type model to try and simplify some of this.